Welcome to Computer Science series. Instance, as a part of SwayamPrabha. This is a course on artificial intelligence and we are in unit 5, which is module 39. This is an agents. Actually, last time we were starting with unit 5, which is NLP, and then in unit 3 and unit 4 it is actually agents. And actually this combined with unit 3, 5 and 4. I have just marked it as unit 3 here, but it is actually a combination of different units. And earlier we did generative AI on the prompt side. I am bringing the prompts into the agentic portion. So I am also connecting the first unit. And last session I stopped with the agent introduction there, where we had the simple agent and the environment, how it interacts. We will follow the same structure, but in the case of using prompt. So it is going towards the generative AI side. Now, what is an agent? An agent does more than answer. It is more than a prompt. Prompt is something that we give an instruction to the LLM and it gives the response. Now, agent, it is actually a series of prompt where it can reason, act and pursue a goal. This we have seen in the unit 1. So, an AI agent, it is a system that takes input, reasons out and act towards a goal or towards the environment rather than only reply, and it has to reason out towards something else and not only giving a standalone response. Now, in order to reason out and get the information, we are going to use LLM. So, it has to use sometimes memory, it can use tools in the sense external tools, something like a calculator. We can ask the agent to fetch the calculator or fetch the computer programs or the decision logic, that those are called as the tools. And it has to evolve with some decision logic, again with the help of the models within the LLM, and it has to solve reliably such that a human would be getting more information to it. Say for example, a tutoring agent, it can explain a concept, remember the confusion and follow up questions. The next would be what are the agents, what are the components within an agents. So here 4 basic components are given, but it can be even more. Like from the LLM part of it, it is the instruction or the role, where we define how the agent should behave based on the instruction. Say the example here is you are a CS tutor who would be teaching undergrad students. Another component is the memory, and the agent, how much memory it should store, and why it is necessary is it has to store the previous conversation history with respect to the user, and while responding to the instruction it has to refer back to those history. So that is why the memory is essential. Third component is the tool. So along with the history and the instruction that is there, it has to interact with external tools that is beyond its capacity. So we can explore this also. Say for example, web search, the calculator or database or weather insights, number of tools we can ask the LLM to search for and get back the answer. Fourth component is a goal or policy. What is the ultimate goal that the agent would try to achieve? So this is in fact very important in order for the agent to establish some task. So the example is generate a current plan. Say suppose we are designing a lesson plan. The goal of the agent would be to give a correct lesson plan. See the word which is correct. It can generate a plan, but how can it be a correct one? So these are basically 4 major components within an agent. Now coming to the types of agent, it is a single agent which we are seeing here. Single agent and multi-agents are there. Multi-agent is actually one part of the unit where we will be focusing now. And before going into multi-agents, we are seeing what a single agent is. Single agent in the sense only one agent that is capable of taking the task and completing it and giving the result. So, one agent handles the full flow and it gets the task, reasons about it and produces the result, and it does not delegate to other tasks, but it does the task. Example would be FAQ bot. Suppose we are designing FAQ for the website. So, the single agent can do the task, grammar checker or summarizer. These are examples of a single agent, and the advantage with this agent is it is easy to implement it rather than the multi-agent. Different types of single agents are there. First one is the stateless, in the sense there is more memory incorporated within it, and as a result no history is needed, or previous conversation is not there. So, it need not remember the history of it. So, whatever the input that it gets, only based on that information the LLM would act according to the stateless agent. In stateful agent, it remembers certain history, and when we take that history, we have to think about the context window in LLM, and when we think of the context window, that directly applies to the cost. So, based on the context window, we might have to pay that amount to that particular LLM. And the third type is tool using agent. It calls search, code, API or databases or calculator, the external tools, in addition to the memory or other details. The fourth is the goal oriented, which we have dealt. It has to plan multiple action, it has to do, plan and act in multiple ways in order to go to the particular objective. On the other hand, stateless is just a single answer alone. Now, we will talk about the first type of agent, which is stateless agent. In the stateless agent, if you see this diagram, there are two different questions. Based on one question, the agent is processing and gives back the result, and question 2 gives back the result, and there is no interconnection between question 1 and question 2. In other words, no memory is carried, there is no history of it. The advantage is it is simple, it is predictable and it is very easy to implement. It is one time classification, example is one time classification, a direct question and answering. Like for example, if we ask what is the capital of France, it will straight away give Paris. And the next question, suppose we ask in this country is it cold or hot, that it cannot go back to the previous question, it will just give what is it. Say the LLM will not be able to distinguish it as France or Paris. This is good for translation, one time classification or question and answers. And as I said, there is no shared memory. The second type of single agent is stateful agent, where the memory is there, a memory in the sense the previous history will be stored as some type of memory. So, first time we ask questions, it will store as a memory, and then turn to we ask other question, it can relate to that memory in order to give a better response. So, the same thing is given here, stores prior conversation and uses memory to produce more follow up and recalling. Such as recalling that a students asked about overfitting, and this overfitting example we will do it as an implementation also. And where it can be used for tutoring. The reason is the student can ask multiple questions that can be saved into the memory. It can be customer support with and assistance with continuity if that is needed. Wherever it is continuous portion is needed, there we would be using stateful agent. And say if we compare that with the stateless agent, it requires careful memory management techniques. So, implementation here is slightly difficult with respect to that of stateless agent. Say a practical example here is, as I mentioned, a tutor that remembers that the student is struggling with how he is able to understand overfitting. Third type is tool using agent. Here external tools such as web search, calculators, code execution or APIs can be used. Say it combines language reasoning and real world application. So this is a say this is the flow that we have given here, where there is a question, the agent is there, and suppose the agent is asked to go and search in the net. So it can go and search or call other APIs to get back the result. Say for example, a weather agent should suppose we ask what is the weather in London. So the question is weather in London, the agent should go and search, it should invoke the API of weather and fetch the result of weather in London and then give back the answer. So this is an example of tool using agent, which is the third type. The fourth is the goal oriented agent, where it focuses on a specific target rather than only one question. Say for example, it can plan, act and revise until the goal is reached. So it would iteratively go on until we have the goal, it has to achieve to that particular objective. So the input here we will give as goal along with the instructions to an LLM. The agent will plan and it will act and then will complete. Some examples listed are report generation, scheduling, content creation or task completion. A particular example here would be, can an LLM create a lesson outline with examples and exercises? So why this is goal oriented is, along with the lesson outline, it has to check back again and again whether it is forming to that particular syllabus, whether it has examples, whether the outline has exercises. It would iteratively go and see all these conditions in order to achieve to that goal, and hence it is called goal oriented agent. And it has to do multiple actions either sequentially or parallelly, but only a single agent. And we have seen the different types of agent. Why these are not always sufficient? Because one reason may be context growth. There can be large number of actions that may be needed. A single agent is not sufficient in order to complete the entire type of all actions possible. And since one agent, ideally one agent should be possibly doing only one role, and one agent cannot do all the roles and it would lead to confusion. Say one role does all, it creates confusion. Example is research, writing, planning, checking or reviewing. They have different actions, and while coding those different actions, there might be it might be very difficult to implement it. So, and the debugging also is going to be difficult when we write the code. Scalable is another issue, in the sense for one agent having all the actions put together as a code, it cannot be scaled properly. It cannot go into multiple limits. So, therefore, we may need multiple agents to do different tasks and then combine together. So, complex task may require more than one generalized agent. Like for example, if we take the research writing agent, which we will be discussing in the next slide, it would be better if there is one agent for research, one agent for writing and one agent for reviewing and one agent for critique. So, then it might be much better than a single agent. So, therefore, we are going into the multi-agent system, where instead of one agent, there is a team of agents than one agent. So, it contains multiple interacting agents. Say the example that I gave in the last time, there is one research agent, the writer agent and the reviewer agent. All the three interacts in order to give the final output. So, while we say it is feasible, but it is difficult, somewhat difficult to implement. And why do we use a multi-agent? And because when we use multi-agent, it can be specialized, and in single agent it was generalized. Here it is going to be specialized, and we can decompose the task to that particular agent so that the task becomes feasible and we can achieve the goal properly. So, For example, the different agents, we can specialize in different tasks. Like if we take the same example of research writing, for one agent for research, one for writing, one for checking or presenting. And if we have a large task, it can be split into smaller subtasks with particular goals. And while we do that, some tasks can run in parallel and some can run in pipeline in a sequential way. So we can assign some agents wherever in parallel, a parallel task, so that task can be done fast. Say here is an example workflow of multi-agent system. So there's one research agent, this is a pipeline method, writing agent, then the verification agent, and then the presentation. So this is a multi-agent that can focus on each task in a sequential way. So that forms the pipeline which I said earlier. This is one type of multi-agent approach where one agent concentrates on research, another agent on writing tasks such as research, a third agent on review, and the last one as output. What is the disadvantage with this method? Suppose there are some hiccups here at this stage, that will reflect at the output. The second type of multi-agent is, another pattern is the planner executor. A planner is a different agent where the agent's job is to create only plan, and that planner will assign it to the executor. So the executor agent carries out planner step by step. This executor agent may be one agent or multiple agents, and these can either say go in a sequential method or can operate in parallel. So an example is plan a lesson first, then generate notes, examples and exercises in order. So the lesson and examples can go in parallel. So this is an example of planner and executor. The third pattern is planner, executor and critique. Apart from planner and executor, so there is one planner agent, executor agent, and the critique agent is one which corrects the planner and the executor. Suppose the execution is incorrect or the planning is incorrect, the critique gives the suggestion and it goes iteratively until we get to this goal. So the planner defines the strategy, executor performs that action, and the critic corrects it, verifies it and corrects it, and the reviewer checks whether the generated is correct, and it can move in a much accurate way. And the difference between a single agent and multi-agent is given in this slide, where if based on the structure, single agent handles only the workflow, multiple agents would be dividing the work. The strength is very simple here it is, and it is generalized in single agent. In this multi-agent, it is specialization and it is more modular. The best use for a single agent is focused, well-defined tasks, something like FAQ bot or summarization. In multi-agent, it is broad or multi-stage workflow, something can go in parallel. For overhead single agent, it is lower coordination task, there is no coordination required here. Whereas in multi-agent, the agents has to coordinate among themselves in order to get to the goal. So that actually is on the higher level. How to choose which agent? Choose the simple, we will start with the simple single agent, and as per the need, we will go ahead with multiple types. So if it is focused with well scoped task, then single agent is essential, and if the task requires a linear way, a sequential way, then it is we can have a single agent. If it needs specialization, then we need multi-agent, and multi-agent also, if it is going to be pipelining or parallelly, we can design it separately. With multiple stages, we need again a multi-agent. An example, say rapid prototyping or debugging of code, then we will start with single agent first, and as per the need, we will increase the agents that can perform the specialized task. So now we will do a short implementation of the agents using Colab. And if you see the Colab, I have used the same model here, like what we did in the last session. We call the open router API key. I've used the same model, and this code is to implement the agents that we have seen earlier. Okay. And as described in the last session, the first step would be designing the model. So, the model, the same part of code is here. The first 3 lines are the specification of the user data. User data is got from this portion where we are getting the Google Colapse data, the requests and the JSON. And like last time, I am using only the open router API key. These are the same 3 lines that like last time, and the same model here, Neomotron 3 from open router, and a similar structure for a response is also given here. And this code I have actually given for wrapping up the text, but it is not necessary. This is for the output text to be wrapping to a particular limit. I have given this type of code. Okay. The first example is the stateless tutor. This is the agent with this is an example for stateless agent. This for This is an example for stateless agent where we are giving the prompt for the tutor. Say the prompt we are giving is what is overfitting in machine learning, and the prompt is you are a CS tutor for first year students, explain the answer clearly in about 2 short paragraphs, avoid formulas unless necessary. So, this is the prompt that we are giving, and the response that the model given is here. These are the response that the model gives. Now, adding to the previous prompt, if we give how to rectify it, say what is overfitting and how to rectify it is an additional question in continuation with the previous one. See, this question, this prompt I purposely gave so that the model should give back the result that it cannot understand. The reason is it using a stateless model. Stateless is it does not have memory. So, ideally what is overfitting in machine learning and how to rectify it, there is no relation between these two. So, we are just checking whether the model also says that there is no relation. So, actually it gives the answer correctly. It looks like you did not paste the specific error message. So, the model does not understand that it refers to overfitting in machine learning. So, this is an example of stateless tutor where the history is not recorded. Actually, if we have ideally the model should refer back to overfitting and machine learning, and it should give back the answer. That is not there here. So, why? Because only based on this prompt it gives, and only based on how to rectify it the prompt is given. The two prompts are not related to each other. So, this is the first type of agent. The second type is stateful conversational agent, where here we are having the history. If you see the Python code, the history has a list starting with a list, and we are appending the list here. The transcript, this conversation history, we are appending it as a transcript, and using this stateful agent, the conversational agent, as see this conversation history append. So, each time when we give the prompt, it is appended as a history, and when we say I do not understand overfitting, it appends. See, earlier this is the prompt, the first prompt, and then continuing with that I do not understand overfitting. This overfitting is attached with the earlier prompt and then gives back the result. And this is another prompt in continuation with the previous prompt, I do not understand overfitting. Can you give small example along with I do not understand overfitting? So, combining with the history, the model gives these answer. And this is another prompt in continuation with the previous prompt that is given with respect to exam style explanation how or overfitting, it gives this suggestion. So, you could see that in stateful tutor the previous conversation was recorded pretty much as a list here that helps LLM to describe the response in a more accurate way. The third type of agent is the tool using agent. So, here if you see the example here, the tools that I have used here is misconceptions and question, where this misconceptions within the brackets is actually a Python function that we are passing here. Get overfitting misconceptions is a function. So, this is an external tool that we are getting from Python and we are passing it into this tool using agent as a prompt. See here. The fourth is the goal oriented agent. The prompt that we are giving is, you are a CS instructor. This is the role that we are providing. The goal here is create a structured mini lesson on the topic, and for first year student these are the audience, this is the context lasting about some minutes. This duration minutes we can give outside. So, and the LLM should give learning objectives. We are also specifying how it should give as bullet points, the short explanation, simple example and questions with answer. And why it is called as a goal oriented agent? Because it not only gives some generated text, but after generating the text it should see that there are learning objectives with exactly 3 bullet points. Again it should go and check whether it is an explanation with only with 2-3 paragraphs with one example. So, it should generate proper lesson plan attached with our constraint. And this is an example for multi-agent pipeline. In this case, we are defining small 3 different agents: research agent, writer agent and critique agent. For each of the agent, we are defining the function. This is the researcher agent with prompt, and this is the writer agent with prompt, and this is the critique agent with prompt. Now, with all the 3 agents, this is the topic that we are going to give to LLM for those 3 agents. So, the topic is using mobile phones in classroom. Stage 1 would be the research. This is a pipeline type of multi-agent approach. Stage 1 is research. So, the notes research agent should generate the research notes. Stage 2, based on the output of research 1, should go to the input of the second stage agent, which is writing, and the output of writing agent should go into the input of third one, which is the review agent. So, you can see the response that it gives. So, in essence what we have done is we have implemented as some types of agent and a demo of multi-agent also I have shown here. So, in similar way you can also try out different agents and you can also build up a small application using React. Okay. So, in this session we have talked about different agents, both theoretical as well as an implementation type. So, that completes our course on AI. In the next session, I will give you an overview of the entire AI what we have done in this course. Thank you.